So in essence, what has happened in this process is we've generated a pyramid where we can do coarse computations here at the top of the pyramid and fine computations at the bottom of the pyramid. Again, by just doing this recursive, using this to compute this one, using that, and going up the pyramid. And of course, we can move down and up the pyramid to do whatever kind of processing we want. So now we know that given any G0, I can compute G1 using the reduce function in a recursive manner. So replace this by G0 and I can get G1. Now the question is, if somebody gave me G1, could I actually compute something equivalent to a G0 or some application that could be used to generate something similar to it? Basically, there is a function called expand, which lets you take any value from here or information that is from here to generate this. Let's look at an example of that and we'll talk about it in a bit. Now I'm going to show you what the output would be from this function if you were just given G1 to create a version of G0. Of course, we will call that G01, and that's what the image looks like, which basically implies that it's G0, but actually expanded once from here to get there. Now, for those of you looking carefully, you may see, oh, not much of a difference. Just to see what the difference is, what I'm going to do is I'm going to take the expanded version of this image and subtract it from the original image. So this is what you see now here. And this is basically, of course, showing you where the differences are. You notice a lot of high frequency information is much more visible. The eye lines and all that kind of stuff are much nicely defined. In basically, you can see that this is the output, which actually is basically showing you the error in reconstructing it backwards. Remember, G0 was the original image. G1 was the one we got by using reduce. Then we basically said, let's come up with a function that takes the reduced image and expands it back to the original, which is G01. We did this from the original one. That's why this is G01. And of course, when we subtracted it, this is what the image we got. So in essence, the expand is the inverse of the reduce, as basically attempts to add new values between known ones. Again, remember the example when we went by an 8x8 simple one to generate a 4x4. In essence, what we're trying to do is going from a 4x4 to an 8x8, in essence, meaning we will be adding new values. Of course, there will be error and we want to be able to measure it. In this case, again, just to get the notation correct, G01 was basically attempting to get the value from G0 by just being able to expanding once. In essence, in general terms, Gjn is Gj expanded n times. Remember, we could even go from G2 to G1 all the way to G0. So recursion is possible this way, where we go from G0 all the way to Gn, or G, larger numbers, or we can go now from our Gn, the level that we're at, back all the way here.